Assalamu alaikum. Hi guys, my name is Atta and today topic is about aerodynamics. Aerodynamics is the study of motion of air, particularly when affected by solid objects such as airplane wing. It involves topics covered in the field of fluid dynamics and in the subfield of gas dynamics and is an important domain of study in aeronautics. The term aerodynamics is often used synonymously with gas dynamics, the difference being that gas dynamics implies the study of motion of all gases and is not limited to air. The formal study of aerodynamics began in the modern sense in the 18th century, although observation of fundamental concepts such as aerodynamic drags were recorded much earlier. Most of the early effects of aerodynamics were directly toward achieving heavier than air flight, which was first demonstrated by Otto Lindley in 1891. Since then, the use of aerodynamics through mathematical analysis, empirical experimentations, wind tunnel experimentation, and computer simulation has formed a rational basis for development of heavier than air flight, the number of other technologies. Recent work in aerodynamics has focused the issues of other related. Aerodynamics in other fields. Engineering design. Aerodynamics is a significant element of vehicle design include road cars and trucks, where the main goal is to reduce vehicle drag coefficient, and racing cars in which addition reducing the drag goal is to increase overall level of downforce. Aerodynamics is also important in the prediction of forces and movements action on sailing vessels. It is used in design of mechanical components such as hard drive, and structure engineers resort to aerodynamics, particularly aeroelasticity, where calculating winds load to the designing of larger builds, bridges and wind turbines. The aerodynamics of internal passages is important in heating, ventilation, gassing and piping, and in automotive engines, where detailed flow patterns strongly affect the performance of the engine. Environmental design. Urban aerodynamics are studied by town planners and design seeking to improve amenity in outdoor spaces or in creating urban microclimates to reduce the effects of urban pollution. The field of environmental aerodynamics describes the ways in which atmospheric circulation and flight mechanics affect ecosystems. Aerodynamic equations are used in numerical weather prediction. Aerodynamic problems are classified by the flow of environment or properties of the flow, including the flow speed, compressibility, and viscosity. External aerodynamics is the study of flow around the solid object of various shapes, evaluating lift and drag on the airplane or shock wave that form in front of nose of the pocket are the example of external aerodynamics. Internal aerodynamics is the study of flow of passages in solid object. For instance, internal aerodynamics encompasses the study of airflow through a jet engine or through an air conditioner pipe. Aerodynamic problems can be classified according to the weather of flow speed, blowing near above the speed of sound. A problem is called subsonic if all the speeds in the problem are less than speed of sound. Transonic if speed both flow above the speed of sound are presented normally when the characteristic speed is approximately the speed of sound. Supersonic when the characteristic flow speed is greater than the speed of sound, and hypersonic when the flow speed is much greater than the speed of sound. Aerodynamicists disagree over the precise definition of hypersonic flow. A rough definition considers flow with Mach numbers above 5 to be hypersonic. The influence of viscosity on the flow details a third classification some problem may encounter over a small viscous effect in which viscosity can be considered and negligible. The approximation to these problems are called implicit flows. Flows which viscosity cannot be neglected are called viscosical flows.